Welcome to our module on HVAC and cooling systems. Today, we'll cover the basics of HVAC and key components, best management practices, and energy-saving opportunities. We will explore industrial HVAC concepts, components like exhaust fans and chillers, best management practices, and resources for further learning. HVAC systems, which include heating, ventilation, and air conditioning, are essential for maintaining indoor air quality and comfort. Key components include exhaust fans, makeup air units, chillers, and heat exchangers. Exhaust fans remove indoor air contaminants and maintain air quality. They should operate based on ASHRAE and OSHA standards and are often located on ceilings or high walls. Best management practices for exhaust fans include evaluating motor performance, ensuring fans run only when needed, and balancing air pressure. Using direct drive fans and ECM motors can enhance efficiency. Makeup air units balance exhaust by supplying outdoor air and often include a burner to heat the air. These units can be highly efficient but require careful monitoring to maintain balance and prevent energy waste. To optimize makeup air units, monitor pressure, adjust supply fan speeds, and use other heating systems when exhaust is minimal. Balancing exhaust and supply air prevents negative pressure issues. Radiant heating directly transfers heat to objects without heating the air, making it ideal for areas with high ceilings or frequent door openings. It can maintain comfort with lower energy input. Effective radiant heating requires highly reflective and insulated reflectors, unobstructed line of sight, and using AHRI-rated units for efficiency. High-volume, low-speed HVLS fans move air throughout large spaces, improving comfort and reducing heating energy costs by destratifying air. Install HVLS fans in high ceiling areas without obstructions. Operate them continuously for cooling during occupancy and for destratification during heating seasons. Chillers are used for cooling processes, equipment, and spaces. They come in air-cooled, water-cooled, and evaporative condensed types, each with specific applications and efficiency considerations. Optimize chiller performance by using variable speed drives, maintaining regular inspections, and ensuring proper sizing and load management. Regular maintenance is crucial for efficiency. Heat exchangers transfer energy from one fluid or gas to another without mixing the contents. They can be used in processes to either cool or heat the fluid, going to the area where it is needed depending on the end use of the fluid. There are several types of heat exchangers, but the most common are shell and tube and plate and frame. Shell and tube heat exchangers consist of a bundle of smaller pipes placed inside a larger shell. One fluid passes through the tubes while the other flows through the shell. Plate and frame. Plate and frame heat exchangers are made up of a stack of thin metal plates contained in a box or frame. The hot fluid flows through every other plate while the cold fluid flows through the alternate plates. Heat exchangers can have three types of flows depending on how they are set up within a process. 1. Parallel flow. Both fluids enter from the same side of the system and flow in the same direction throughout the heat exchanger. This flow type is most commonly found in shell and tube heat exchangers. However, parallel flow is the least efficient method for effective heat transfer. 2. Concurrent flow. The hot fluid enters from one side while the cold fluid enters from the opposite side. The flows cross paths, exchanging heat and exit on opposite sides. Concurrent flow is the most common method and more efficient than parallel flow. 3. Cross flow. The hot and cold fluids enter at opposite ends and flow perpendicular to each other. This is the most efficient flow method available in heat exchangers. Maintaining a preventative maintenance schedule is essential for optimal performance. Periodically checking the temperature differentials between the hot and cold sides helps ensure consistency. During yearly checkups, efforts to reduce scaling and fouling on the heat exchanger should be incorporated into the preventative maintenance routine. Additionally, evaluating the flow direction and considering alternative methods can improve the efficiency of the process. To recap, we've discussed HVAC components, best practices for exhaust fans, makeup air units, radiant heating, HVLS fans, chillers, and heat exchangers. Now, let's test your knowledge. 1. What is a key best management practice for exhaust fans? A. Monitor pressure to balance air. B. Speed up supply fan if exhaust is too great. C. Destratify air by decreasing speed. D. None of the above. 2. Which flow type is best for heat transfer in heat exchangers? A. Parallel, B. Concurrent, C. Cross, D. None of the above. Thank you for watching. Stay tuned for more insights and strategies in our upcoming videos.